In this lecture, we are going to learn about how to find out the conformal mapping of the transformation W equal to F 1 by Z for the half plane x greater than C when C is greater than 0 and for the half plane y greater than C when C is less than 0. So consider the Z plane x greater than 0. For that we have to find out the image under W plane. Here W equal to 1 by Z can be rewritten as Z equal to 1 by W, which gives you x plus iy equal to u minus iv by u square plus v square. By comparing the real part, you will get x equal to u by u square plus v square and y equal to minus v by u square plus v square as an imaginary part. Next, we are considering the line x greater than c in z plane. So, x greater than c you can write as u by u square plus v square is greater than c. Now doing the cross multiplication, you will get u is greater than c into u square plus v square. Therefore, u square plus v square is less than u by c. Now we are going to make it as a perfect square pattern. So bringing this u by c to the left hand side, we are going to get u square plus v square minus u by c. To make it as a perfect square, here we are having u square and minus u by c, we are going to connect it. Therefore, I can write it as u minus 1 by 2c. Let us try it out. The whole square. What is it going to be? U square minus 2 times of u into 1 by 2c plus 1 by 2c square. So 2 gets cancelled. We are having u by c. Therefore, we are having the term u square here and u by is here. To make it as perfect square of this pattern u minus 1 by t 2c the whole square pattern, we have to add and subtract 1 by 2c because 1 by 2c the whole square is not present in this inequality. So add and subtract 1 by 2c so that it won't affect this equation. Now here adding and subtracting 1 by 2c, you will get u square or u minus 1 by 2c the whole square plus v square, okay, e is less than minus 1 by 2c the whole square will become plus 1 by 2c the whole square. Therefore, it represents the circle with center 1 by 2c comma 0 and radius is 1 by 2c. Here this is less than 1 by 2c the whole square, therefore we have to consider the interior of this circle. So u square plus v square minus u by c less than 0 is the interior of the circle with center 1 by 2c comma 0, radius 1 by 2c. How we are having this sentence can be understood by the help of this calculation part. Now we are drawing the picture. We are having the line x greater than c in the z plane. For that, first we have to consider x equal to c. x equal to c means it is a straight line passing through the point c comma 0. X greater than c means the portion lies right hand side of this line x equal to 0. Then that is mapped onto the interior of the circle with center. Let us take this point as 1 by 2c comma 0 where c is positive. So when c equal to 1 you are going to have 1 by 2 comma 0. That's why we have taken this point as 1 by 2 comma 0. And radius is also 1 by 2c, that is half when c equal to 1. When c equal to 1 it represents 1 by 2 comma 0. Radius is also 1 by 2. That circle, after drawing it, we have to consider only the interior part of it. Hence, x greater than c is mapped onto the interior part of the circle. Therefore, we can observe that the straight line in the z-plane is mapped onto a circle, interior part of the circle in w-plane. Likewise, we are going to find out the straight line image, okay, in w-plane. The straight line here is y greater than c. So for that first we have to consider y in terms of u and v. What is y in terms of u and v? We have seen that y equal to minus v by u square plus v square substituted there. So minus v by u square plus v square is greater than, here y greater than c. Let us take c as negative, therefore let it be minus k. So y is greater than minus k. Therefore minus v by u square plus v square is greater than minus k. Now here minus sign, here also in the left hand side, right hand side also minus sign. Therefore it will change the inequality like k is greater than v by u square plus v square. Or we can write v by u square plus v square is less than k. By doing the cross multiplication, we'll get v is less than k times u square plus v square, or u square plus v square is greater than v by k. Now again, by making use of perfect square form, this I can write it as u square plus v square. By bringing it to the left hand side, minus v by k is greater than 0. Now here I am going to write the perfect square in terms of v. How can we write? It can be written as u square plus, we can write it as what? Here v minus, let us write it as 1 by 2k, the whole square. What it could be? V square plus 1 by 2k, the whole square, minus 2 times of v into 1 by 2k. So 2 gets cancelled. We are having this term, and v by k term also we are having. So the missed out term is 1 by 2k the whole square. If we are writing v minus 1 by 2k the whole square, this term is included, but here that term is not included. So you are going to write it as v square minus v by k plus 1 by 2k the whole square minus 1 by 2k the whole square is greater than 0. Now bringing this minus 1 by 2k the whole square to the right hand side, you will get u square plus these three terms we can combine it like v minus 1 by 2k whole square is greater than 1 by 2k the whole square. So what it represents? It represents a circle with center 0, 1 by 2k and radius is 1 by 2k itself. but it is greater than 1 by 2k. Radius is greater than 1 by 2k. So you are going to consider the portion exterior of this circle with center 0, 1 by 2k and radius 1 by 2k. Now by drawing the picture, y is greater than c where c is less than 0. Therefore, let it be c equal to minus k. So y greater than minus k. K can be any positive value. Therefore, you will get y greater than minus 1, y greater than minus 2, y greater than minus 3. Like that, it goes on. This k we are fixing here. Let it be this point is minus, that is 0, minus k. It is a line passing through the point 0, minus k. So greater than means this portion you are going to have, and exterior of the circle having center 0, 1 by 2k and radius is 1 by 2k. So exterior means outside. Okay. Hence, we have drawn the image of the line, okay, half plane x greater than c is the interior of the circle, and half plane y greater than c when c is negative gives you the exterior of the circle with center 0, 1 by 2k and radius is 1 by 2k. Hope you understood this problem. Now next we are going to move on to the bilinear transformation. What is bilinear transformation? The definition states that the transformation W equal to AZ plus B by CZ plus D, where A, B, C, D are complex constants and AD minus BC is not equal to 0 is known as bilinear transformation. So how to remember this transformation? To remember this transformation, write down A plus B divided by C plus D, then multiply A with Z and C with Z. That's all. So W equal to A Z plus B by C Z plus D. Here A, B, C, D in the denominator, where A, B, C, D are complex constants and this determinant AD minus BC not equal to 0 is known as the bilinear transformation. This bilinear transformation also called as Mobius transformation. The other name of bilinear transformation is Mobius transformation or linear fractional transformation. Now, the inverse mapping of W, AZ plus B by CZ plus D is, what is that? W equal to, here if I am considering the inverse mapping, 1 by Z, you will get Z equal to minus WD plus B by CW minus A, which is also a bilinear transformation, bilinear. So you can see here it is a linear equation in the numerator as well as linear equation in the denominator. So it is called bilinear transformation. Now in this bilinear transformation, we are having the important concept called fixed points. What do you mean by fixed point? Fixed point means the transformation, okay, the image of the point under the transformation is itself. The image of the point under the transformation is itself. That is, here if W equal to Z itself, then we can call Z is a fixed point of the transformation, or we can call it as a invariant point of the transformation. So how to find out the fixed points? For example, here you are having the bilinear transformation W equal to Z by Z minus 2. To find out the fixed point or invariant point, just you have to equate this bilinear transformation to Z itself. So put W equal to Z, you will get Z equal to Z by Z minus 2. Now by doing the simplification, we can able to get the fixed points. or the points which are invariant. So by doing the cross multiplication, you will get z square minus 2z equal to z. Bring the z to this left hand side, you will get z square minus 3z. So this z square minus 3z equal to 0 can also be written as what? Z into z minus 3. Now by equating it to 0, you are getting the points as z equal to 0 and z equal to 3. These are the two fixed points of this bilinear transmission. So to get the fixed point, just equate the bilinear transmission to z itself. This is very important. Now, you are having the property of bilinear transmission that is called cross ratio property. What is that cross ratio property? Consider four z-plane points, okay, or 4 points in z-plane. Let it be z1, z2, z3, z4. Then the cross ratio of this 4 points is going to be, if I am taking z1, z2, z3, z4, how to remember the formula? The numerator is going to be z1 minus z2 and z3 minus z4. The denominator is going to be z1 minus z4 into z3 minus z2. So it is easy to remember. The numerator is first two numbers difference multiplied by third and fourth number difference. The denominator is first and fourth and then third and second. So this property is called cross ratio property. This cross ratio property of a bilinear transmission is invariant. So the cross ratio of 4 points is invariant under bilinear transmission. Therefore, what is it? The images itself. So by considering 4 points in W plane whose images are Z1, Z2, Z3 and Z4 under a bilinear transmission. So by cross ratio property, you can write down the invariant points as, you have to keep this in mind, okay. Same like you are going to write W1, W2, W3, W4. So numerator is going to be W1 minus W2, W3 minus W4. Denominator is going to be W1 minus W4 and W3 minus W2. That's all. Same thing you are going to do it in Z plane also. Z1 minus Z2 into Z3 minus Z4 divided by Z1 minus Z4 into Z3 minus Z2. First, you have to write down the cross ratio property of bilinear transmission. That you can write in terms of W also in left hand side. So it is easy to write down the cross ratio property. Nothing to worry about it. The numerator is difference between first two numbers multiplied by difference between third and fourth number. The denominator is going to be difference between first and fourth multiplied by third and 2. Please keep this in mind. So this is the cross ratio property of a bilinear transmission which is invariant. Okay. Now the bilinear transmission which transforms the points Z1, Z2, Z3 of Z plane respectively into the points W1, W2 of W plane is given by, here if you are having only 3 points, the first point can be taken as W in W plane. Likewise, the first point in Z plane can be taken as Z itself. So how to write it out? W, W1, W2, W3. W1 minus W1 multiplied by W2 minus W3. Denominator is going to be W minus W3 into W2 minus W1. Suppose if you are considering in terms of W1 minus W2, here usually we are having W2 minus W1. If you are having W1 minus W2, you have to take minus sign from this term also, that is W3 minus W into W1 minus W2. That's all. Both are going to give the same answer only. Equal to, in terms of Z you have to write Z minus Z1 into Z2 minus Z3 divided by Z1 minus Z2 into W3 minus, sorry, Z3 minus W, Z3 minus Z. Okay. Now consider this example. Find the bilinear transformation which maps the points Z equal to 0 minus I minus 1 into W equal to I 1 0. So we are going to take the points as Z 0 I minus 1 into W I 1 0. How to write it out? By making use of cross ratio property only, we are going to find the mapping. Okay. To find the mapping, we are going to write it as Z minus 0 into minus I minus I1, minus of minus I1, that will give you minus I plus 1 divided by minus 1 minus Z, then 0 minus of minus I. Likewise, W minus I 1 minus 0 divided by 0 minus W into I minus 1. You can see it here. I think it is understandable. W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W. So take W as W itself and W1 as Y, W2 as 1, W3 as 0. Then Z as Z itself, Z1 equal to 0, Z2 equal to minus I and Z1 equal to minus I. This is Z3. Z2 equal to minus I and Z3 equal to minus 1. By substituting in the formula, you will get W minus I into 1 minus 0 divided by I minus 1 into 0 minus W equal to Z minus 0 into minus I plus 1 divided by minus 1 into minus Z, minus 1 minus Z multiplied by minus 1 0, not minus 1 minus I 0. Now we have to do the simplification. So this is going to be 1 into W minus I divided by W into I minus 1. W minus I divided by w into or minus w into I minus 1 equal to z into 1 minus I divided by I into minus 1 minus z. Now we are doing the cross multiplication. So do the cross multiplication. You are going to have minus sign we are taking outside. It will be I minus I into. So minus I into w minus I into 1 plus z equal to z into 1 minus I into minus w into I minus 1. What is the thing we have to get here? We have to get that bilinear transformation, that is w equal to az plus b divided by cz plus d format. So to get that, we have to do the simplification. Here, multiply it inside minus I into w, okay, minus iw, I square is minus 1. So I into minus I is plus I square is minus 1, so minus 1, okay, into 1 plus z. Now by doing the multiplication, we are going to get minus I into w minus I into w is z minus 1 minus z. Okay. Then likewise here doing the multiplication, let it be z minus iz into minus wi plus w. So again by doing the multiplication, you are going to get minus wizi plus wz. Okay, I square is minus 1. So plus into minus 1 minus w into z minus I into wz. So these two gets cancelled. You are having minus 2 times of iwz. Therefore here we are having iwz term also present in left hand side. Here it is minus, here also minus. Therefore if you are bringing this side, you will get plus. So iw minus iwz plus 2iwz equal to, bring these two terms to the right hand side, z plus 1. Therefore, you are getting minus iw. By doing the subtraction, you will get iwz equal to z plus 1. Now, taking w common, you will get zi minus I equal to 1 plus z. So, w equal to 1 plus z divided by zi minus I. Now, you can see that it is of the form w equal to az plus b divided by cz plus d, where a, b, c, d are complex constants. So you can do the simplification further by taking w equal to 1 plus z divided by minus I. If I am taking common, you will get 1 minus z. So az plus b, a equal to 1, b equal to 1, c equal to, you are having I, d equal to minus I. Therefore, it satisfies the bilinear transformation format. So how to find out? Here, if you are having the finite numbers as given, okay, you can take the fourth number of z plane as z itself. Here also w plane, w itself. Therefore, you are going to consider z, 0 minus I minus 1 and in W plane Wi10. Now use the bilinear transformation cost ratio property. It is invariant under bilinear transformation. Cost ratio property is invariant under bilinear transformation. Therefore, by making use of that formula, we are getting this and substitute it and bring the form as W equal to AZ plus B divided by CZ plus D, where A, B, C, D are complex constants. Hope you understood. Now we'll move on to the next problem. Here, find the bilinear transformation which transforms the points z equal to infinity I 0 into the points w equal to 0 I infinity respectively. So here infinite point we are having, therefore we can consider it as z, okay, infinity, okay, I 0 into w 0 I infinity. So the numerator is going to be z minus n infinity into I minus 0 divided by 0 minus z into infinity minus I. Likewise, you are going to have w minus 0 into I minus infinity divided by infinity minus w into 0 minus I. So use the cross ratio property which is invariant under bilinear transformation. Substitute all the points. You will get it as like this. Here why we are writing like here z1 is infinity. That z1 wherever you are having the infinite point, you have to replace it by see z1 equal to we are having infinity. The same infinity can be written as what? 1 by 0. Okay, so this z1 can be replaced by 1 by say z1 dash. Likewise, you are having w3 equal to infinity. This w3 infinity can be written as what? It is equal to 1 by 0. So w3 equal to 1 by w3 dash. Okay, that replacement we have to do it here. So here you are having w minus w1 into, okay, w3, w2 minus w3. How we are getting denominator w3? Take that infinite point outside. w3 into w2 minus w3, w2 by the w3 minus 1. Likewise, the denominator also w1 minus w2 into 1 minus w by w3 into w3. Take that infinite point outside. Likewise, in z points also, okay, here z1 we are getting it as infinity. Therefore, you are going to take z1 outside. Z by z1 minus 1 into z2 minus z3 divided by z1 into 1 minus z2 by z1 into z3 minus z from this formula. Which point is infinity? Take that point outside. Now, before applying infinity, you have to cancel these points. Then, now apply the points w minus 0, okay, into what is this? W2 divided by infinity. 1 by infinity, we know that it is 0, okay. 1 by 0 is infinity. Likewise, 1 by infinity is 0. So, by putting 1 by, any finite value divided by infinity gives you 0. So, W2 we know that the point W2 is what? You are having I. W3 is infinity. So, by substituting W2 divided by infinity, you are going to get what? This is 0. Okay. Likewise, this term 0, this term 0. Okay, so this entire term going to be 0, this entire term is 0, this entire term is 0, and this entire term is going to be 0. Then after doing this simplification, you will get the answer very quickly. So w minus 0 into 0 minus 1 divided by 0 minus 1 into I minus 0 equal to 0 minus 1 into I minus 0 divided by z minus 0 into 0 minus 1. In what manner we have to bring? We have to bring it as w equal to az plus b divided by cz plus d, where a, b, c, d are complex constants. So if you are bringing in this pattern, you can stop the procedure. This is the bilinear transformation, provided AD minus BC not equal to 0. So by substituting this, we have to do the simplification. This gives you what? W divided by minus I equal to minus I divided by minus Z. So minus sign gets cancelled. You are having W by I. You are going to bring this I to the right hand side. So you are getting W equal to I square is minus 1. Okay. Therefore minus 1 divided by Z. Now it is of this form only. How? Here A is going to be 0. B is 1. C is 1. D is 0. Okay. A is 0 here. B is minus 1 here. C is 1 here. D equal to 0. Therefore, this is the required bilinear transformation. Hence, if you are getting the infinite points, you have to do the careful simplification like this. Before applying infinite point, you have to take that infinite point outside and cancel it in a common way, and then, okay, any finite value divided by infinity will give you 0. So by substituting it, you will get the answer by doing the simplification. Thank you all. Hope you all understood, I think. Thank you.